Hi guys, today we're going to talk about literal equations. Literal equations are just equations that have multiple variables. A lot of you may have called them formulas. Those are the types of things we're looking at today. We're going to start with a little warm-up, so if you want to pause it and work ahead, that's fine. We're going to solve this. This is not a literal equation. This is just an equation in one variable. Most of us would start by distributing. You would have 10x plus 8 equals 3x minus 6. Some of you like to move the constants first. I like to get my x's together first. That's my personal preference. Either way works. 7x plus 8 equals negative 6. I'm going to subtract 8 from both sides, and I'll get 7x equals negative 14. And we'll finish up by dividing by 7, and we will get x equals negative 2. This is a one-step equation, and a one-variable equation. When we're doing these literal equations, a lot of the process is the same. It's just going to have lots of variables everywhere. So let's look at this. On a trip to Canada, you may wish to convert Celsius to Fahrenheit. Given the following formula, determine the temperature in Fahrenheit if it's 15 degrees Celsius. So you probably have seen this formula before in your science classes. They're asking us, if Celsius is 15, can you figure out what Fahrenheit is? Now there's two ways to do it. I told you that a lot of you would just really like to distribute. And that's not wrong, but it's going to make this problem a little bit more complicated. And I'll show you that in a minute. What you probably could do here is our goal is to get f by itself, so we really just need to move these two pieces. So I'm going to move the 5/9 first by multiplying both sides by 9/5. It's not wrong if you said you wanted to divide by 5/9. That would be the same thing. You can type this in your calculator, or you could say 15 divided by 5 is 3 by cross-simplifying here. 3 times 9 is 27. So 27 is f minus 32. And then to finish up, you would just add the 32, and the Fahrenheit temperature is 59. Now, let's say that you really couldn't handle it, and you really just had to distribute. Okay, remember there's a 15 here. So that would be 15 is 5/9 f minus, you would have to type in your calculator. Oh, I don't know what I just did there. What are we going to type in our calculator? 5/9 times 32. So you're going to take 5 divided by 9 times 32. It's going to give us a decimal. If you hit math 1, it will change it to a fraction for us. That's 160 over 9. So 5/9 f minus 160 over 9. Now, you could multiply through everything by 9 here if you saw that, but most of my students, I believe, would have started doing this. Add the 160 over 9. And that's fine. If you take 15 plus 160 over 9, I already had the 160 over 9 there, but 15 plus 160 divided by 9, enter math 1, I get 295 over 9. So now I have 295 over 9 equals 5/9 f. Now you can either divide by 5/9 or multiply by the reciprocal, 9/5. If you multiply by 9 over 5, those 9s will cancel out. 295 divided by 5 is just what we had before. 59 equals f. Distributing is fine. It will get you where you're going, but it would have been easier to not distribute in this example because we were just trying to get that f by itself. Let's look at some more examples. Isolating a variable. Don't let all this extra letters scare you. All you do is solve it just like it's a regular equation and just leave all the variables in their places. So if we're trying to get m by itself, you first will need to move the p away. We will do that by addition. And I will get n plus p equals 2n. To get n all by itself, you would divide by 2. When you divide by 2, you divide the whole entire thing by 2, and you get n equals n plus p over 2. Now, there's other ways this guy could look. You could have also, when you had the n plus p equals 2n, said I'm going to multiply by 1/2. If you multiply this side by 1/2, you would multiply the whole entire left side by 1/2. You could leave it like that. That would be fine. Those are what we call equivalent. You also could have distributed that, and you could have had 1/2 m plus 1/2 p. That also would have been acceptable. And you actually can write this guy as m over 2 plus p over 2. All of those answers would have been acceptable. Okay, next we're looking at velocity. The final velocity of an object moving in one dimension is given by this formula. V equals u plus at. U is the initial velocity, a is the acceleration, and t time. We are trying to get t by itself. So what would we move first? Well, to get t by itself, we're going to have to move this u away first. So v minus u, and just leave them side by side, and that equals a t. To get t all by itself, you would divide both sides by a, and once again, you get something that looks like this. V minus u over a equals t. I don't know why I put that extra equals sign here. Other ways that could look, very similar to the last one, 1 over a times v minus u. You could add v over a minus u over a. I think that's mostly it. All right, let's see what else we have here. How about this guy? A equals 1/2 base times height. We're going to try to get height by itself. This is the area of a triangle. To get height by itself, the first thing I prefer to do is to move that fraction. You could move two things at once if you wanted, but I'm going to multiply both sides by 2. So now I have 2a equals bh, and I'm going to divide both sides by b, and I'll get 2a over b equals h. Okay, so these are the properties that we know so far for equality. We have your addition property, your multiplication property, your transitive and distributive. The next one we're going to talk about is the square root of property. And what it says is that if a squared equals b, you are allowed to take the square root of both sides. But if you do take the square root of both sides, you're going to have to make sure you do a plus or minus, because there are two numbers. If x squared equals 4, and you take the square root of both sides, you cannot just say x equals 2, because while 2 squared does equal 4, you also have to consider the negative 2. So anytime you say the words take the square root of both sides, you're going to want to make sure you remember to say plus or minus. So let's look at this guy. You have bx equals y squared minus c, and we're going to try to get y by itself. So the first thing we will do is we'll add the c. And we get bx plus c equals y squared. Now, to get y all by itself, we will have to take the square root of both sides. Because I said the words take the square root of both sides, you need a plus or minus here, and you will have the square root of bx plus c. So don't forget your plus or minus. Okay, here is P equals 2 times the quantity, L plus W. And they're asking us to use two different methods here. And this is kind of what I was talking to you about before. If I'm getting W by itself, we can just get rid of the 2 first and then the L. We would do that by dividing first. You would divide both sides by 2, and you would get P over 2 equals L plus W, and then to get W all by itself, you would subtract L. And that would just look like P over 2 minus L equals W. You could have distributed first, and you would have P equals 2L plus 2W. Getting W by itself, you would subtract 2L, and you get P minus 2L equals 2W, and you would divide both sides by 2. P minus 2L over 2 equals W. This and this are actually equivalent. They look different though. So how can you tell if they are the same or if you made a mistake? Well, there's a couple ways you can do it. You can use algebra. If you knew algebra, you would know dividing by 2 is the same thing as dividing both pieces by 2, which would be P over 2 minus 2L over 2, and they just simplified those 2's to get this. But let's say you didn't catch that. What you can do is you can show they are equivalent by using variables. Let's say that L equals 10 and W equals 20. If L equals 10 and W equals 20, if these equations are the same, I should get the same thing for this perimeter. So the perimeter is supposed to be 2 times 10 plus 20, so 2 times 30, and it's supposed to be 60. If I plug 10 and 20 into both of these, will I get 60? So 60 over 2, we're going to see if this is true. Minus 10, does that equal 20? Well, that's 30 minus 10, that equals 20. This one works out. Let's try this guy. The perimeter was 60. 60 minus 2 times 10 all over 2. 60 minus 20 over 2. 40 over 2, does that equal 20? It does, and you can show that they are equivalent by using some variables to plug in and test. Okay, check all the equations that are equivalent then. So let's see, you can use algebra or you can plug in variables. So what else is equivalent here? Well, what is the thing that they did on this guy? It looks like they were getting 2a together. So the first thing, let's do some variables here. Let's say that B1 is 10, B2 is 20, and B3 is 5. So what would the area be? Area would be 1/2, oh, not B3, excuse me. This will be H. 1/2 of 5 times 20 plus 10 is 30. So we typed on our calculator. We get 75. So the area is 75 when these go together. So we're going to check these all out and see if they're equivalent. So what would 2a be? That would be 2 times 75. Does that equal H, 5 times B1, which is 10, plus B2, which is 20? This will be 150. Does that equal 50 plus 20? No. The second one is out. Let's try the next one. B1, we have that as 10. Does that equal 2a, which would be 2 times a, or 150, divide by h, which is 5, minus 20? 150 divided by 5 is 30 minus 20. Does that equal 10? Yes, this guy works. How about the last one? B1, that's 10. Does that equal 2 times 75 minus 1/2 of 5 times 20 all over 5? Well, 10 equals 75 minus 0.5 times 5 times 20. This will be 25. So 2 times 25 over 5. Does that look like it works out? 2 times 25 is 50 over 5. This last one works out as well. So the top one and the bottom two are all equivalent. The work accomplished by two people working on the same task is given as this. Then they make it look like this guy. They were wanting us to solve for t. The original equation says W equals R1t plus R2t. And then all of a sudden, we write it like this. If you are solving for a variable and it shows up multiple times in the equation, you need to try to factor out a GCF, which is what this step did for us. Both of these equations have a t in common, so they pulled it out and they wrote t times R1 plus R2. That makes it significantly easier to get t by itself because you could just divide both sides by that entire quantity, R1 plus R2. If you divide both sides by this entire quantity, R1 plus R2, then you get T equals W over R1 plus R2. So it started like this, and they had to pull out the GCF so that they could divide both sides. If what you're looking for shows up more than once, that is what you will have to do. And then this last one, we're going to use proportions. When you're solving for something that's in the bottom of a fraction, it might be nice for you to get it at the top level. You can do that by cross multiplying or multiplying everything by e. So on this one, we will go ahead and cross multiply. When you do that, the whole numerator must be multiplied by e plus, and then this will be multiplied together as well. Why did I put plus? I'm rewriting this. Mrs. Bruno is tired. What we're going to do is cross multiply. So the product of the means equals the product of the extremes. This a plus b times e, I'll put the e in front, has to equal CD. If you have a proportion, the cross products are equal. That's because it's saying a fraction equals another fraction. Does everyone agree that 2/4 is 1/2? Anytime a fraction equals a fraction, the cross products have to be equal. 4 times 1 equals 2 times 2. That always happens. If I have 2/4 and 18 over 36, that equals 72, and that equals 72. That's what happens with equal fractions. So once we have gotten rid of the fractions, now we can get e by itself. Yes, you could distribute here if you wanted, but it will make it more challenging for you. You would have to go back and factor it out. To get e by itself, the only thing I need to do is divide both sides by that quantity, a plus b, and I'm going to get CD over a plus b. So lots of solving equations today. You'll have a homework assignment as well, and we'll look at our quiz for next week.